This video is about the division properties of exponents. The goal of this video is to simplify using the law of exponents. So there's two laws with division of exponents that we're going to review today. The first one is the quotient of a power. So to divide powers having the same base, we are going to subtract the exponents. And there's two different examples here. Now, the thing you have to be careful about is wherever the higher exponent is, that's where your base and the new exponent is going to end up. So in the first example, we have 9 as the larger exponent, which means when we subtract our exponents, we're going to end up in the numerator of the fraction. So we could have an over 1, but we don't need that over 1. That's why just 3 to the 6th. In our second example, we have an exponent of 5 in the bottom, which is the denominator. So at the end, we're going to end up in the denominator with our answer. So you need to pay attention to where your higher exponent is. If it's in the top, you end up in the numerator. If it's on the bottom, we end up in the denominator. So, number 1, we have g to the 19th over g to the 12th. 19 is the bigger number, so that means our variable is going to end up in the numerator. So we just have g to the 19 minus 12. There's nothing in the bottom. If you want, you can put a over 1 on the bottom to show what happened. And our final answer then is just going to be g to the 7th. Number 2, we have 5 to the 8th over 5 to the 17th. So 17 is the bigger number, which means we're going to end up in the bottom or the denominator of our fraction. So this time we have to put a 1 to show that we had a numerator. And then we have 5 to the 17 minus 18, so we have 1 over 5 to the 9th. When your simplified answer ends up in the denominator, you have to have an over 1 up in your numerator. Number 3, we have 10y to the 4th over 8y to the 9th. So 9 on the bottom is the larger exponent. We're also going to reduce our fraction. So we can reduce our fraction by taking a 2 from each factor. So now we have 5 on top. On the bottom we have 4, and then we need to subtract our exponents. 9 minus 4, so we get 5 over 4y to the 5th. Number 4, 10v to the 9th over 20v. Remember that a v has an exponent of 1. So I'm going to take out 10 from both factors to reduce my fraction. So I now have 1 over 2. The 9th power is higher, so we're going to end up in the numerator. So v to the 9 minus 1. So we end up with v to the 8th over 2. Number 5, now we have two variables. We have d to the 9th, f to the 30th over d to the 12th, f to the 5th. So we need to look at each variable separately. So when I look at the d, 12 is a bigger exponent, so d is going to end up in the denominator, 12 minus 9. F, 30 is the bigger exponent, so it's going to end up in the numerator, 30 minus 5. So we get f to the 25th over d to the 3rd. Number 6 has everything going on. So first we need to reduce our constants, so we can take a 4 out of both. So you're left with 2 over 3. When I look at my m, 15 is my bigger exponent, so we have m to the 15 minus 9. 20 is bigger than 4, so q to the 20th minus 4. So our final answer is 2 over 3m to the 6th, q to the 16th. Our second property is the power of the quotient. So what we do here is we distribute the exponent to the numerator and to the denominator. Remember, if there's already an exponent there, we're going to multiply it out. So here's an example just to see what it would look like. So in number 1, we're going to distribute this 3 to both exponents. So now I have 3 to the 9 times 3 and 8 to the 3 times 3. I'm going to multiply my exponents. So I get 3 to the 27th over 8 to the 6th. Same thing in number 2. We're going to distribute a 9. So we have h to the 2nd times 9, g to the 4th times 9. That simplifies to h to the 18th over g to the 36th. Number 3, we have 5v to the 3rd over w to the 9th, all raised to the 10th. So this 10 has to go to everything. It has to go to my 5, to the v with the exponent, and the w with the exponent. So we now have 5 to the 1 times 10, v to the 3 times 10, all over w to the 9 times 10. So when I simplify, I get 5 to the 10th, v to the 30th, and w to the 90th. Let's try that one more time. In number 4, we're going to distribute a 5 to everything. So we have 7 to the 1 times 5, f to the 2 times 5, g to the 3 times 5 in my numerator. In my denominator, I have 9 to the 1 times 5 and h to the 4 times 5. So I would end up with 7 to the 5th, f to the 10th, g to the 15th, 9 to the 5th, and h to the 20th. Since they're all different bases, there's nothing else I can do, and I would just leave my answer in the simplified form. Number 5, I need to distribute a 2. So I have r to the 8 times 2, x to the 3 times 2, over x to the 9 times 2. So I get r to the 16th, x to the 6th, over x to the 18th. Now, we have an x in the numerator and the denominator. So I'm going to use my property I learned earlier. X to the 18th is bigger. So r to the 16th stays on top in the numerator. And in the denominator, I have x to the 18th minus 6. So once I subtract those, I get x to the 12th. Number 6, we're going to distribute the 4. X to the 3 times 4, y to the 7 times 4, over x to the 2 times 4, and y to the 3 times 4. So we get x to the 12th, y to the 28th, over x to the 8th, y to the 12th. Now, we have 2 x's again, and 12 is my larger exponent. So we have x to the 12 minus 8. We have 2 y's, and 28 is our larger exponent. So we have 28 minus 12. Now, there's nothing left in the denominator because those were both the lower exponents. So I don't need to put anything on the bottom. So my final answer is just now x to the 4th and y to the 16th.